If you are watching this, it is because you need a little extra practice solving by square roots. So make sure you have the white packet. We're going to take a little bit of notes on the back, and then we'll do a few problems on the front, and you can do the rest. So this first little bit of notes, we're going to take a look at what standard form is. And then from standard form, we'll do a few problems. So standard form is ax squared plus bx plus c equals 0. Notice it's an equals 0. And the way that solving by square roots works is either when this is missing, so no linear term, or else you see something in vertex form, which looks like this. So either one of those forms works best with solving using square roots. So let's take a look at a couple problems. We're going to do number 3 and number 4, and then we're going to talk about what happens when you don't get a perfect square. So number 3, see it's in vertex form, and the way you solve these is by getting rid of all the extra stuff first. We want to isolate that squared term. So we'll add, subtract first, and then multiply and divide. This is based off of PEMDAS that you remember. But when you solve, we do PEMDAS backwards. So add, subtract comes first. So let's subtract 4 from both sides. Divide by -3. And now we are up to this piece right here where we do exponents. In order to get rid of the squared exponent, we square root. So that leaves this side. The left side is x minus 7. And this side as square root of 9 is positive and -3. So then the last step, to get x by itself, we're going to add 7 to both sides. And this is where people usually struggle doing this. This is positive 3 plus 7. It's also -3 plus 7. It's 2 different ones. So I get 10 and 4 as answers. Okay, now number 4 is in standard form. It's not in vertex form, it's in standard form, but notice b is missing. There's no linear term. So we're still going to do PEMDAS backwards. We're still going to do the add, subtract first. So that's 4x squared equals 64. And then we'll divide by 4. X squared equals 16. And now we are up to the exponent piece. So we'll get rid of the square by doing square root. And we end up with x equals positive and -4. Now notice when it's in standard form, you get a positive and negative, same answer all the time. But when it's in vertex form, you actually get 2 different answers. So keep that in mind. All right, so those so far all had perfect squares when we square rooted. But what happens when it's not perfect squares? So let's look at number 10. Again, vertex form. So we'll add 40 to both sides. Divide by -2. And notice this is not a perfect square. We have that negative in front of the 25. So when you take the square roots, it's positive and -5i. So to solve the rest of this, we'll subtract 5. But we cannot combine 5 with 5i. So we have to write our answer as 2 separate pieces. -5 plus or minus 5i. It's usually convention that we put the integer first. So there's your answer. It is 2 different answers. You can write -5 plus 5i and -5 minus 5i, or you can put them together like this. So number 11 is pretty similar. We're going to take a look at number 11. This one's in standard form. Let's do PEMDAS backwards by adding 48 to both sides first, and then dividing by 4. Now when we take the square roots, notice we have a square root of 12, not a perfect square. So this is where you split it up into 2 square roots, 4 and 3. This becomes 2 root 3 then. So our answer is positive and -2 root 3. So you've seen all the different kinds of answers you can get with this, but you still follow the same pattern. Add, subtract first, then multiply, isolate that x squared. Then take the square roots and find your answers. So if you need more help, see your teacher. You can rewind this video and play with each kind of these problems, but get the extra practice you need to pass this